YouTube, what's up? And this video is going to be a compilation of all the labs I've done so far for the CCNP in this channel. Going to be about 1 hour and 30 minutes. I try to make every lab as quick as possible and to the point. Hopefully you guys enjoy. Good luck. YouTube, what is up? So today we're going to be doing some labs. Again, I got a lot of good comments from you guys in the CCNP videos, the Encore, the ENARSI. So the next step is logically to help you guys figure out what labs to do. Today we're going to be doing a lot of labs that I did for the ENARSI, and then maybe another day I'll do some more labs for the Encore to show you guys. Stick around, this is probably going to be an hour-long video. What I'll probably do is I'll post this whole video on raw, uncut, and then I'll grab it, shorten it up for each different topic. For example, this topic we're going to be doing right now is going to be a DMVPN lab. So let's go ahead and get right into it. So the first thing you're going to want to do to really recreate this, and I'm going to let you guys know, I'm going to give you guys like the configs, like I'm going to be doing it step by step, because what I personally never like doing is hopping on a YouTube video and someone will show you the topic, but they leave out like a certain config that makes it work, and then you're just like stuck trying to troubleshoot for 30-40 minutes. Like, that's a good learning process, you got to figure it out, but for the sake of being transparent, I wish more people would like show the full config so you can see, oh, that's why that happened, you know? But, so first thing you're going to want to do is have a router, basically be your ISP router. You can think of this like the cloud almost, going to the internet. So ISP router or the internet, you can consider it. And then you're going to want to have a branch router, 2 branch routers really, branch 1, branch 2 is what I call it, and a hub. So DMVPN, you guys should already know what it is if you've been studying for it. So really, we're just going to be talking about how to configure it. What I'm going to do is show you guys how to do phase 1, phase 2, and phase 3, and talk about the differences, and then we'll move on to the next lab. So I'm going to start this up. We're in Cisco modeling labs right now. Let's give it some time to start up. While that starts up, what we're going to be doing is we're going to configure next hop resolution protocol authentication on this. We're going to be doing, freaking hair from my dog somehow. We're going to be doing static IP to MBMA address maps with the whole time configured network ID, all that. We're going to do that on the other branch router as well. And then we're going to be doing this phase 2 and phase 3 so you guys can see the difference. And while that waits to start up, let's go ahead and talk about some things we're going to be doing on the hub. So on the hub, you already see here I put the IP addresses, so hopefully that's more helpful. But we're just going to be configuring the IP addresses on the interfaces, and then we're going to be setting up the tunnel. I'm going to name tunnel 0, and then we're going to be setting up everything that goes into it, like the authentication. For authentication, it's going to be something like IP NHRP authentication. I'm going to do CCNP 123, for example. Alright, here we go. They're starting up, so let's get right into the hub. Let's go. Let me move this up a little bit. Hopefully you guys can see this good. So boom, enable, we're going to go config host name hub. Boom, interface gig 1. IP address, what is it? 10.10.255.10/32. Boom, no shut. Exit. We're gonna go into the loopback interface. Loopback 0. Gonna give it IP address 10.10.1.1 and that /32 since it's the loopback. You don't really need to do no shut, but I like to be extra safe. Gonna get out of there, and then we're gonna configure the tunnel interface. Tunnel 0, IP address, boom, 192.168.1.254, 255.0. Boom. Now we're going to start configuring the DMVPN. So really so we're going to set up the hub completely right now, but then so you guys can see on the branch routers, we're just going to set it up normally, and then we're going to be moving on to the steps to configure the branch routers to be able to talk with the hub through the tunnel. Alright, so next step is next hop resolution protocol, authentication, CCNP 123. IP next hop resolution protocol, network ID, we're going to do 100, hold time, 5 minutes, which 5 minutes, it's actually in seconds, so 60 times 5, 300. Alright, IP next hop resolution protocol. Let's see, next hop server. The next hop server is usually always the tunnel address. I'm gonna do a MTU for this. And also the maximum segment size. Boom. We're going to give it a tunnel source, 10.10.255.10, which is the physical interface gig 1 that we did earlier. Tunnel mode, GRE, multi-point. We're going to do the key, tunnel key 100. Going to exit. We're going to put EIGRP on it. 100. Network 10.10.255.0. Boom. And that's it. That's it for the hub. That's it for the hub. Now we're gonna configure the ISP. Let's go. Alright, boom, enable. ISP is gonna be simple, host name. Jesus, I'm not even. Host name, ISP, interface, gig 3, boom, IP address 10.10.255.9, put it on the /30 subnet, boom, no shut, let's do interface gig 1. And we're going to do IP address 10.10.255.1, another /32. Boom, no shut, exit, interface, gig 2, IP address 10.10.255.5/30. Boom. No shut. And oh no, actually we gotta go back into EIGRP. 100 network 10.10.255.0. Alright. So now let's hop into the interesting piece, which is the branch routers. So let's start off with branch 1 first. Boom. So branch 1, real simple. Let's give it the host name first. BR1. Gonna go into the interface, gigabit 1. Gonna give it IP address 10.10.255.2, 255.255.0, and we're gonna do a no shut. I'm just looking at my notes here so we can go through this quickly and you guys can see again step by step everything I did on my notes to configure this. So boom, no shut. We're not gonna configure the tunnel because I want you guys to understand what we have to do to set up the DMVPN. So right now we're just doing the physical interfaces. That's it. That's all we're doing right now. So I'm gonna hop on branch 2. Enable, const hostname BR2, interface gig 1, and we're gonna do IP address 10.10.255.6. 255. .6, boom. No shut. Exit. So right now, can branch 2 or branch 1 talk to the hub? So let's see. Do ping 10.10.255.10. Boom. We can. Do show IP route 10.10.255.10. And boom, it's known via disconnected route, and then after that, EIGRP is finding it. Alright, so let's go ahead. When you have connectivity already between the actual physical or underlay, I should say, this you gotta think about the tunnel like an overlay network under the physical underlay network. So now we know the underlay network has connectivity, so now we're going to be setting up the tunnel or the overlay. So to accomplish this, we're going to go to BR1 and we're going to start setting up the tunnel. So boom, interface tunnel 0, IP address 192.168.1.1, 255.255.0. We're going to be setting up the authentication like we did at the hub so they can talk to each other. CCNP 123. IP next hop resolution protocol map is always good to into your head. This helped me a lot in my CCNP. I realized the first IP address is always the tunnel, and then the second one is the actual physical. So try to remember that if you can. So boom, the tunnel IP of the hub, and then the physical IP of the hub. Alright. IP next hop resolution protocol. Then after the map, you hit it with the map multicast, and that's just gonna be the physical interface again. Gonna do the same network ID. Gonna do the same hold time, 5 minutes or 300 seconds that we talked about earlier. And then we're gonna do the next hop server, which is gonna be the tunnel IP address, not the physical. So boom, next hop server, and then we're gonna be doing IP shortcut. Boom, IP MTU 1400, segment size 1360, tunnel source 10.10.255.2, tunnel destination 10.10.255.10, same tunnel key as the hub 100. Boom. So you already see some messages are coming up. We're gonna go set up, you see the tunnels up right here. We're gonna go set up the branch 2 router, and then we're gonna test connectivity between the tunnel. And again, because we're using tunnel destination on the command that we did earlier, for example right here, this makes it phase 1 DMVPN. If we were to move to phase 2, we would change the tunnel interface to tunnel mode GRE multipoint and remove the tunnel destination command. Alright, so let's go to branch 2, and it's gonna be really the same thing, just with different IPs. Interface tunnel 0, IP address 192.168.1.2, 255.255.255.0. Boom, authentication, CCNP 123. Map. What did we say the first thing is? The first thing is the tunnel. So boom, the tunnel IP of the hub. Then the physical interface. Boom. The map. Multicast is just gonna be the physical. Alright. Boom. Network ID. What did we say was 100? And then the whole time, again, 5 minutes. Let's go. Almost there, almost there. Next hop server, again, that's gonna be the tunnel. The total IP address. Boom. Let's go, let's go. IP next hop resolution protocol shortcut. Boom. Do the MTU. 1360. And then we're gonna do tunnel source 10.10.255.6. Tunnel destination 10.10.255.10. Tunnel key 100. Boom. Alright, so let's get out of there. Alright, so moment of truth. Can branch 1 or branch 2 through the tunnel get to the hub? Can it? Let's find out. You see it's coming up. So let's go ahead and do a ping 192.168.1.254, which is the hub. Boom, successful. Now let's try to ping branch 1 through the tunnel from branch 2. Boom, successful. Let's do a trace route so you guys can see. Damn, my nose itchy though. Alright, so trace route 192.168.1.1. It should go to the hub because we're doing phase 1 right now. So let's wait for it. So the hub's IP address, and then it's gonna get to the branch 1 eventually. There we go. All right, so let's go ahead and make this phase 2. So before we do that, let's do a show running interface tunnel 0. Boom, so we can compare branch 1, branch 2, and let me do this, probably be better for you guys. Boom, branch 2, bada bing, bada boom, hop up in the room. What's up, baby? Pitbull, bro, it's Saturday, bro. You guys gotta forgive me, bro. I'm in the Saturday mood. Alright, I don't even know what I'm typing. Show running, not config. Show running interface, tunnel 0. So boom. Let's go over the config real quick. So the IP address, the MTU, authentication, you see they match. The map again, tunnel, physical. Map multicast is always gonna be the physical. The network IDs match, hold times match. Next hop server is this, the tunnel IP of the hub. And then we're gonna do shortcut, tunnel source, tunnel destination. Again, this makes it phase 1. So let's go back to branch 1, boom, interface, tunnel 0. We're gonna do no tunnel destination 10.10.255. We're just removing that command. And now we're gonna do mode GRE, or what is the command? GRE multi-point. Jesus, I haven't done this in a while. Tunnel mode GRE multi-point. Tripping. Tunnel mode GRE multi-point. Boom. Alright. Straightforward. Let's do it here. CompT. Interface. Tunnel 0. You see it comes back up and it still works because we still did the GRE multi-point. So the tunnel goes down, but it comes right back up. Interface tunnel 0. No. Tunnel destination. Let's copy that. Paste. Boom. Tunnel mode. GRE multi-point. So should be coming up now. Boom. It comes up on branch 2. Let's go ahead and do a trace route. Make sure we still got connectivity. Boom. Even though we know what's up, let's make sure we got connectivity. That trace route, don't even see what happened because the notifications kept coming up. So let's do that again. So boom. Because it's phase 2, it's really like phase 3 where it can go spoke to spoke. It doesn't have to go spoke to hub. So you see this is a little different than we did earlier where it had to go through the hub. We saw the first hop going through the hub. So it would have traveled branch 1 through the ISP to hub. It's not going to show ISP because it's the tunnel. It's basically going straight to the hub. So instead of doing this little triangle motion, it went straight to boom, branch 2 because it's phase 2. Now, let's go ahead and do phase 3. Alright. But before we do that, so spoke tunnels are typically point to point in phase 1. And in phase 2, again, phase 2 and phase 3, just reading over my notes here to let you guys know the same thing that I wrote down. Spoke tunnels are configured as multi-point GRE tunnels. Basically, when we do the tunnel mode GRE multi-point command, allowing them to dynamically establish direct spoke-to-spoke tunnels. So basically what that means is what I said earlier, that now it's just spoke-to-spoke. You don't see that those 2 hops. You just see the hop directly to the next branch. So to make this phase 3 real simple, we're going to go to the hub, show running interface tunnel 0. Does it have the IP NHRP redirect? No. So to make this phase 3, literally that's the only command we need in theory. So interface tunnel 0 IP NHRP redirect. So now this is considered phase 3 because it's redirecting. So that's phase 3. So you guys see it was pretty simple to set that up. You guys really, again, you're going to get this a lot. I got a lab like literally similar to this on the test. And all I can say is doing this, I think I did this lab over maybe 20 times. Again, you got to really make it like muscle memory. You got to remember the commands. Notice how I had the little reminders in my head, like the first IP when doing IP NHRP map is the tunnel, and the second is the physical. You get that confused, you're going to mess the whole lab up, you're going to be troubleshooting. So make sure you understand that. Make sure you know how to set up the whole time. Make sure you know how to do phase 1, phase 2, phase 3, all the differences, because it might ask you, hey, make this from phase 1 to phase 3. It might ask you something like that on the test. So you got to understand the differences, all right? So that is the first lab. Let's go ahead and stop this. All right. Boom. YouTube, what's up? In today's video, we're going to be doing some more CCNP labs that I did to pass my CCNP ENARSI. And Encore, this one is more geared towards the ENARSI. So as you can see, I got a Cisco document pulled up here. Configure VRF leaks on iOS. So this is a cool lab to do because it talks about VRS. You got to configure BGP, EIGRP, and then you have to actually leak those routes amongst themselves from a VRF, which in this case was going to be VRFA, into the global routing table. So this is cool. This lab, I'm going to tell you guys one thing that was giving me issues when I was first doing it and studying it was route targets. So we're going to talk about that at the end and why it was giving me such a hard time, but route targets and route distinguishers are really important to make this thing work. So I'm just going to go through the introduction like the document goes through. I see a lot of CCIEs talk about how important it is not just to do Google searches or get an answer for ChatGPT. It's really important to look at actual Cisco documents. And after going through this lab from a Cisco document, I can definitely agree. So this document describes and provides examples, configurations for common methods of VRF route leaking. The scenario I had labbed out is scenario 1. So it's pretty simple. All you need is 3 routers. One of them, like the diagram shows, you're going to configure for BGP. You're going to configure, for BGP and EIGRP on each indicated side for the VRF. And then the last one, EIGRP. Now, little bone to pick. Obviously, I don't know how to configure this just from looking at the topology and what needs to be done. But when I show you guys the configs here in a couple seconds, I can definitely see like a beginner maybe having a rough time if they're trying to go straight into this. So this lab, you really needed prior knowledge of doing labs with BGP, IGRP, and all that, because someone that's never configured BGP is probably going to go in here and like, okay, how do I make this work? Address families and all that. So that's my only bone to pick because it doesn't go into that. But I guess it is what it is. But luckily for you guys, if you're new to all this stuff, I'm going to be going through line by line config to make sure everybody understands what I did and can follow that step by step. Alright, so before we head into the lab, let's keep looking at this. So ideally, when you set this all up at the end or at the beginning, you're going to see the global routing table from leak and the VRF-A routing table from leak. And then after that, you're going to configure, you can either do a route map with a prefix list or access list. And then you're going to do these commands right here, which we're going to go through, redistributed, and then you should see this as the end result, which is, as you can see, VRF-A has global routes, and the global route has routes from VRF-A. So let's go ahead and get right into it. This is let me show you guys this in case anybody's interested in this in the future. So this is a big lab I have set up. I thought I had the routers. I must have deleted them. This is a big lab I have set up that encompasses everything I learned from the CCNP. So definitely drop in the comments down below if you're interested in seeing this whole thing, how it will play out. Warning though, you definitely need a lot of power or on your server that you're running. You could obviously do monolabs from the cloud, but whatever server you're running on, because there's so many nodes, I think I got set up with 96 gigabytes of RAM to run this. So just a FYI, it definitely does require an extra bit of power because it has so many nodes. But you could definitely do this one step at a time. You know, just the top VRF red, then the other VRF blue, maybe even with some loopbacks to skip doing the nodes. But anyway, let's go ahead and get this set up. So let me add the 3 nodes we're gonna be using. I'll fast forward the video while this starts booting up. Alright, so BGP has loaded up, so let's go ahead and start going line by line on this thing. So first thing we're gonna do, obviously go into enable mode, and then we're gonna give it the host name BGP. Then we're gonna start with our VRF definition A, route distinguisher, very important. If you guys don't know what a route distinguisher does, it basically just, like the name says, distinguishes a route. So imagine if I'm BGP and I'm advertising 1.1.1, and I have a route distinguisher of 1.1, it would be 1.1 with that IP of 1.1.1.1, right? So that's the main difference there. Next, we're gonna go into the address family. So address family IPv4, and we're gonna give the route target. So route target export 1.1. When I first was doing this lab, nowhere did it say to do this, but it is very important. I ended up, after doing research, realized how important it is to get that done. Alright, that's why I said I have a bone to pick. Sometimes it doesn't tell you stuff in the configuration. You gotta figure it out on yourself. It is what it is. Anyway, let's keep going and we'll talk about this later. So route target export 1.1, route target import 1.2. Alright, exit out of that. Exit. And then let's go into interface gig 1. We're gonna assign it to VRF-A with the IP address that we saw on the lab topology. Now we'll shut on that. Boom. Now we're gonna hop on interface loopback 0, VRF forwarding A IP address that is talked about in the topology. No shut just to be safe. Exit. Now we're gonna go into the BGP configuration, router BGP1. We're Gonna give it the BGP router ID of 1.1.1.1. Boom. And now we're gonna hop into address family IPv4 VRF8. This is what I'm talking about. Like if someone that's never configured BGP, although it's simple when you start doing it in repetition, this might seem like kind of crazy going in the address family and all that. At least it was for me when I first did it. So 172.16.10.10 with the mask. Boom. I'm gonna do the neighbor 10.00.1 remote autonomous system 1. Neighbor 10.0.0.1 activate. Boom. That's it. That's all you need for BGP. Alright, now we're gonna be moving on to the leak router. This has more stuff on it. Alright, so leak, again, same thing, enable. Let's give it the host name. Leak. Let's give it the VRF. Definition A. Again, super important, route distinguisher. Let's do 1.1. Let's go into the address family. Boom. Let's go ahead and do import. IPv4. Unicast map. Global. This is going to be a route map that we're going to create here in a bit. Global to VRF. Boom. Then we're going to do export IPv4 unicast map VRF to global route target export 1.1 route target import 1.2. Boom. And configure again. And now let's go into our interfaces. Interface gig 1, VRF forwarding A. Boom. Let's give it the IP address with the 10.0.0.1 with the mask 252. No shut. Exit. Boom. Next interface gig 2. IP address 192.168.1.1 255.255.255.0. Boom, no shut, exit. Now we go into router EIGRP1, and then we're gonna advertise the network there. With the wildcard mask. Boom. And now we're gonna go into BGP. Because remember, this has BGP and EIGRP. Router BGP, address family IPv4, VRF8. Boom, neighbor 10.0.0.2, which is the BGP router. Remote autonomous system 1, neighbor 10.0.0.2. Activate. Boom. And now that's done. Let's hop into the EIGRP. Boom, enable, conft, hostname, EIGRP, interface gig 1. Let's give it that IP address, 192.168.1.2 with the mask. Boom, no shut. Exit. Now we go into the loopback 0. IP address in the lab topology 192.168.1.0. 0.0.255. Boom. Okay, what did I type wrong? Oh, tripping. That's my fault. That's getting confused with my ones. 11.11. 255.255.255. Where am I at? Okay, I'm saying 255. Boom. No shut, just to be safe. Exit. Let me see what I got configured. Make sure I'm right. Okay. Now let's go into router EIGRP1, and we're gonna advertise these networks 192.168.1.1 .11.11. Boom. And we'll do this one, even though we don't need to, just to be safe. Boom. You see the adjacency starting to come up. So if we go back to the lab document, it literally tells us this is what we should be looking out for. So show IP route on leak. Let's go ahead and perform that. Boom. Show IP route. So boom, we do see the 192.168 network there, advertised via EIGRP. Now let's do show IP route VRFA, and we see the BGP route advertised in the VRFA. All right. So now what we're gonna need to do is set up those route maps, right? So still on leak. This is what we're gonna do. Let's go into CompT, and we're gonna do route map VRF to global. We're gonna do route map global to VRF. All right, let's exit out of there. Let's go back into the VRF definition, address family IPv4, and then we're gonna do the import IPv4. Boom, unicast map global to VRF, export IPv4, unicast map VRF to global. Let's get out of there, and now let's go into BGP, router BGP1. Let's go ahead and redistribute now. EIGRP, redistribute EIGRP1. Remember, if I'm trying to redistribute EIGRP into BGP, you configure first what you're going into. So because I'm trying to redistribute EIGRP into BGP, that's why I did router BGP first. So redistribute EIGRP1. Boom. Let's exit out of that. And then router EIGRP1. Redistribute BGP1 metric 1500 255 1500. Boom. Do whatever metric you want. Anyway, now because I did the route map, it's just gonna cover everything, right? So I didn't do an access list for it tells you to do access list, but that's just to select the networks. But just for the sake of this lab, I didn't. It's still gonna work because it's gonna encompass everything. So if you do a show running config, we see the route map. Boom, it's encompassing everything right there. All right. So boom, and let's see here. So now let's do a show IP route. Boom. So this is the global routing table earlier. It did not have the BGP route. Earlier, all it had was where's the global routing table that they showed? Earlier, it just had the EIGRP route, right? So now you see the BGP route is in the global routing table. Let's do VRFA now so you guys can see. And now we also have the EIGRP routes. Obviously, it's showing distributed as BGP because the redistribution. So you can see how cool this thing is to actually leak routes, because as you guys know, when you use a VRF, you're basically almost chopping up the router to be able to make more routes unique, but it's also cool to be able to leak them into another router. Maybe if you're an ISP provider and you need to do that to get to your customer site, whatever it may be. So this is a cool technique to know. Now that we got that working, let me go ahead and explain the route targets and why it wasn't working and why it's so important. So literally, don't hate on me, don't get on me. I literally do this all the time for whatever topic, and I'm gonna read it out to you guys. So anytime I have a hard time understanding something, this is what I do. I'll go on to ChatGPT, Gemini, whatever it may be. I'll show it like the config of what I did, how it wasn't working the first time, what I did to fix it, and if I know what I did to fix it is working, but I still don't understand why, I'll go in and say, explain this to me like I'm a middle schooler, right? So this is the answer you will kind of get. So long story short, the trick, which is using the route targets, you discovered was that by using these route target stamps on your VRFs, you were telling the router exactly what information it should go into and out of those secret rooms. It uses secret rooms to basically describe your routes with the route distinguisher assigned to them. So the route target is grabbing that from the route map as well and exporting and importing, like you guys saw when we configured it in the leak router, right? In the leak router, let me pull up the config that we did. We did that import IPv4 unicast map global to VRF, grabbing that from the route maps that we made, which is using a route target also. So really, route targets are just ways of identifying, and it labels how things need to move around. So without those specific stamps, the message or the routes might not be sent correctly, right? Because when I originally was doing this lab, I was getting routes to leak from the global routing table to VRFA, but from VRFA I couldn't get it to go to global. And that's because it probably had a miscommunication because I didn't have no route targets. So if you want to do things properly, make sure you do route targets when you're doing this. Obviously, feel free to look up more on your own route targets and different examples, but this is kind of the example I wanted to provide for you guys. I've seen in the comments you guys want to see more BGP, more EIGRP stuff. That's coming soon. So this lab is out the way. I'm going to be showing you guys another lab soon. Hope you guys enjoyed. If you did, please smash that like button and check out the playlist with my other labs. Catch you guys on the next one. YouTube, what's up? We're back with another video. I think this lab and a couple more, and we're going to be done with this series of labs. Unless you guys want to see more, of course. But for now, this lab that we're going to be doing here is going to be for policy-based routing. So, I've been having sneezing all day. What this lab is going to show is the importance of policy-based routing. So in an enterprise environment or even in a small environment, you might need sites to be more resilient than with just one ISP. So whenever you start working, you will see that some sites are going to have 2 ISPs, maybe even 3, I don't know. But for this example, we're going to be doing 2, ISP-A and ISP-B. So basically what we're going to do is we're going to show how traffic is prioritized through ISP-A, for example. That would be the example of the main ISP at the given time. And then we're going to use policy-based routing to divert that traffic for whatever reason, if needed to ISP-B. Let's say ISP-A is down, or ISP-A is being slow for whatever reason, you could do policy-based routing to activate that. IP SLA can kind of also go hand in hand with policy-based routing, but that's not going to be for this video. IP SLA, just to touch on it briefly, could be used to detect the things automatically and use policy-based routing to activate it automatically. Policy-based routing in this lab is going to be something more manual, but again, we're going to be showing an example from PC1, doing a trace route to the internet and you're going to see it go through ISP-A, and then once we do policy-based routing, you're going to see how it goes through ISP-B. And all policy-based routing is match and set. So you match whatever IP address you want to use, and then you're going to set the next hop. So as you can see, everything's starting to come up here. So first things first, let's start from left to right in the configuration. So here we go. Let's see, are we recording? Yes, we are. Alright, so we're going to go into PC1. We're going to go into config, and we're going to give it the host name, PC1, interface gig1, IP address. We're going to give it 168.10.50, 255.255.255.0. I'm gonna do a no shut, and then we're gonna exit out of there, and then we're gonna do a static route to the gateway, which is gonna be on router 1. So IP route 0.0, boom, to 192.168.10.1. Exit. You can write that if you want. And then on the switch, still booting up. The switch, we're really not gonna do nothing besides just give it a host name. So CompT, host name, switch 1. Alright, boom. Now we're gonna move to router 1. Alright, boom, enable. So router 1. Jesus Christ. I hate that when I don't do the command to avoid that. Now this thing's gonna take forever to boot up. So since I know it's gonna take forever, let's go to ISPN and then we'll circle back to router 1. Alright. ISPA, CompT, hostname ISPA, interface gig 1. We're gonna give it IP address 10.10.10.2, 255.255.255.252. No shut, exit. Now we're gonna go to the interface gig 2 of that, and we're gonna give it IP address 100.100.100.1 with that same /30. Boom. No shut, exit. And now we're gonna go into OSPF. So router OSPF 1. We're gonna advertise the networks 10.10.10.0, 0.0.0.0.3. We're gonna put it on area 0, make it simple. Let's see, the other network is gonna be that 100 with that .3 wildcard mask. Boom, exit. Let's just do a do right. Exit out of there. Let's see if router 1 is ready. It is. So let's go back to router 1. Boom. CompT, space this time. Hostname R1. Interface gig 1. And that's going to be the gateway address that we were talking about earlier, 192.168.10.1, 255.255.255.0. We're going to do a no shut. Let's move on to the other interface, gig 2, IP address 10.10.10.1, 255.252. Guys, I like going through the whole config manually because, again, my complaint when I watch tutorial videos or labs is that they'll skip the config. So I just want you guys to go through it. You can feel free to put this on 2x speed if you want, but I'm going to go through the whole config in case anybody needs help doing the config and not get confused. Alright. Did I no shut that? No, I didn't. Boom. No shut, exit, interface, gig 3. IP address 2020 .1 255.255.255.252. No shut on that. Exit, and then we're gonna go into OSPF. Router OSPF 1 network 10.10.10.0 255 area 0 network 20.20.20.0 area 0. Boom. And one more network 192.168.10.0. Boom, area 0, exit. You can do a do right, save it. Boom. What's left? We just got ISPB left and internet, so let's keep going. Boom, ISPB. Where you at? Alright, ISPB. Boom. Hostname, ISPB. Interface, gig 1. 20.20.20.2. Look at me going too fast. Slow down, boy. No shut. Exit. Interface. Gig 2. IP address 200. 200.1/30. No shut. Exit. Now going to router OSPF. Advertise the networks. One more network to advertise here. 0. Alright, and now the last one, we almost there. Internet router. This is gonna obviously resemble the internet. Let me stop this and wipe it, because that had a config from another lab that I was doing on there. Well, let me start this. Sometimes you gotta go like this. Alright, so the internet one is ready. Let's go into config mode. Boom, hostname, internet, interface gig 2, IP address 100.100.100.2. Boom, no shut on that. Let's go to the other interface. Interface gig 1, IP address 200.200.200.2. Bro, funny story before I keep going. I had first done this lab like the very first time. And for whatever reason, instead of making this 200.200, I had made it 100, 100, 200. And I was troubleshooting for like a good 10, 15 minutes until I realized why a loop was occurring even after the fact I did policy-based routing. And it was because I had the wrong IP address and it couldn't go from gig 2 to the internet. It was going all the way back to ISPA. But I just want to share that because it's funny how one little thing can mess up the whole plan of what you're trying to do, which is again why I like going step by step into the configs to prevent anybody getting confused. No shut. We're gonna do that loop back 0, and we're gonna give it IP address 8.8. Boom. Right, let's do a no shut to be safe, even though you don't need to do it really for loopbacks. OSPF, network 8.8. Jesus. Network 8.8.8. 0.0. Area 0. Network 100.100.100.2.0.0.0. Area 0. 200. Area 0. Boom. Exit. Alright, so before we do the access list to highlight how it's gonna switch from ISPA to ISPB, let's first do a trace route from PC1 to the internet. But before we do a trace route and get stuck in an endless loop, let's make sure this thing works. So can I ping the 100.100.100.2? I can. Can I ping the 200.200.200.2? I can. Alright, so let's go ahead and do a trace route to the internet. Alright? So bada bing, bada boom. We should, in theory, see this go from PC1, from R1 to ISPA to the internet. So let's see what happens. Let's go, let's go, let's go. Hey, if you guys have enjoyed the video so far, please smash that like button and check out the playlist for some other labs we've done as well. I think it's called like CCNP Labs, the playlist. Almost done. So 10.10.2, remember that it's on ISPA, right? So We just verified with this trace route that it's going from PC1 to ISP8 to the internet, right? So let's say, again, ISP8 is being slow, it's down. We need to move traffic to ISPB. This is what we're going to do. So we're going to go on R1, and we're going to make an access list to capture that traffic. And from that, we're going to use a route map to set it to the next hop. All right? So boom, access list 100, real simple, permit IP 192.168.10.0, which is basically the whole network from R1 inside, so the internal network really. So boom, 0.0.255, go into any. So boom, real simple. Now we're gonna do a route map, clients, or we can name it internal to internet. Boom. Now we're gonna do match IP address 100, and then we're gonna set the next hop, which is gonna be the ISPB. So I set IP next hop. Boom, 20.20.20.2. Exit out of there, and now it's not enough to just do the access list and the route map. You also have to apply it on the actual interface. So interface gig 1, IP policy, route map, what did I call it? Internal to internet. Yep. Boom. So that's really all you need. See how simple that was? That's all you need. You need an access list, you need a route map to match the access list at the next hop, and then you need to apply the policy route map on the interface. So let's go back to PC1. Now we're gonna trace route the internet again. So if everything works as intended, no loops, nothing, it should just go straight to ISPB and the internet. So let's see. Boom, hits the router, R1. Should see it go to 20. Yep, 20.20.20.2, which is the next hop that we told it to take. And then this should go straight to that internet. Boom, yep. 200 is on the internet router. So basically real simple, guys. Hopefully you guys kind of grasp the concept a little bit more, why we use policy-based routing. And when to use it. If you ever get a job or work alongside any network person, they're going to tell you they've probably done this quite a bit. Again, guys, if you guys enjoyed this video, please smash that like button. I'm going to make sure to do a couple more labs to show you guys. And again, if you're enjoying the labs, check out the labs playlist. I think it's called CCNP labs. I'll check you guys on the next one. YouTube, what is up? Alright, so boom, next video we're going to be doing OSPF to BGP redistribution. Right now, as you can see on the screen, we have a BGP section, an OSPF section, and thrown in the corner is going to be EIGRP. So we're going to talk about that here in a second. I'm going to give you guys an example question here in a couple of seconds about why this lab came about, and a really good video. I got to give credit where credit is due. This guy right here, Your IT Explained, when I was going for my CCNP ENARSI, I was searching for a video like this, and it got 6,000 views, and it makes sense because this guy really puts it in detail. So this lab that we're going to be doing is basically this lab with my take on it and what I learned from it, plus some added notes on top of it. But again, this video, if you still don't grasp it from what I'm showing you, hopefully you will understand it, because I feel like I'm more relatable, like person to person. A lot of people are real technical. I feel like I'm technical, but I can still relate it, good. But in case you don't understand it after this, definitely go check out this video, troubleshooting redistribution, right? So this was a very helpful video, but this lab is loading up. So while it's loading up and everything, let's go ahead and talk about the questions. So I have this sample question here that will basically describe, it'll show you a router config. All right, it's going to show you the IP routing table, with some connected routes, some OSPF external routes, and some intra-area routes, right? And then it's gonna ask the OSPF routing protocol is redistributed into the BGP routing protocol, but not all the OSPF routes are distributed into BGP. So with that, and then it asks which action will resolve this issue. So we're gonna talk about that in the lab. So in this example, when it's saying not all the OSPF routes are being redistributed in a BGP, what that can mean is your OSPF external, your regular OSPF routes, your OSPF intra-area routes. That's what it means by not all the OSPF routes, right? So sometimes when you're distributing OSPF, for example, the EIGRP, like you see in the corner there, EIGRP can go into OSPF, and then it will be an OSPF external route. And there's something special you gotta do sometimes to redistribute external routes into BGP, right? So enough of that, let's go ahead and get into it. So like you guys know on my channel, I like to go step by step on config. It is a couple of routers here this time around, so instead of typing it all up, I'm gonna copy and paste the config from my document, and we're gonna discuss the configs, or you guys can screenshot as I go through. So boom, first thing, we're in router 1. The first set of commands we're gonna do is really just to give it its IP and set up BGP, right? So boom, again, hostname R1, router BGP, and we're gonna put the neighbor. Make sure to take a screenshot of this in case you need to grasp it in your mind or save it for your notes later. But we're moving on to router 2. So boom, let's go router 2. This one is gonna be similar, same thing, just setting up the IP and the BGP configuration. Boom. Make sure to take again a screenshot of that if you need to. This is the starting config for router 2. We're gonna go to router 5. I know it's not router 3, but I'm just going from left to right from the lab topology. So router 5, nothing real special about this. Just only thing that's different is obviously it needs a config for BGP and OSPF, since it's gonna be the one redistributing between the two domains. So boom, copy that, paste that. I'll give you guys a second to take a screenshot of that if you need it. Alright. Boom. It's gonna be R3. R3 again, this is just gonna be setting up the IP address and setting up OSPF. Boom, take a screenshot of that. That's for R3. Now we're gonna get to R4. Almost done. R4. Boom. Take a screenshot of that, guys, if you need it. Last router here. R0. Or actually, I'll leave off R0. Let's talk about this first. So what we're gonna do now is we're gonna do show IP routes on each router, and we're gonna notice how the different routing domains don't see each other because redistribution is not configured yet, right? So just to go step by step. So boom, let's see. So let's see from R3 basically. Show IP routes. So boom, you see it just has the connected routes. Let's do R4. Show IP route. Boom, it just has the connected routes. And then, show IP route on R1. It has the BGP route going to R5, I think that is. Let's see. R5. Show IP in brief. Yep, R5. So now that we did the show IP routes, now we got that in our mind. Now we're gonna keep moving through the lab, right? So we want to start redistributing so we can start seeing more routes, right? So to start, we're gonna go into R5 because that's the router that's gonna be doing the redistribution. because again, it's right in the middle of the BGP and OSPF domain, so it's gonna be doing all that. So first thing you're gonna want to do is we're gonna redistribute BGP into OSPF. So again, whatever you want to redistribute into, you have to start from there. So I want to redistribute BGP into OSPF. I'm going to start in OSPF. So let's go ahead and do COMT. So router OSPF 1 and simply redistribute BGP 250, right? Now, in theory, and hopefully if I go into R3, right, and I do a show IP route, I should see more routes than I saw earlier. And boom, exactly. Now I'm seeing OSPF external routes, which is these routes from BGP, right? I'm seeing all these routes. Earlier I just saw these right here. But because we're doing redistribution, now obviously we see more routes. Okay? So now let's redistribute the other way, OSPF into BGP. You see how these routes are coming from the BGP section? Now if I hop into R2 later on or R1, I should see routes from the OSPF. So let's go ahead and go back to R5, and we're gonna do router BGP 250 and redistribute OSPF 1. Again, whatever you want to redistribute into, go into that. So I want to redistribute OSPF into BGP, so I started in the router BGP 250. So redistribute OSPF 1. And now let's go out of that. Now if we click on router 1, I should see BGP routes from the OSPF side. So look, these are my routes from earlier, right? So boom, show IP route. I see way more routes, right? Earlier I didn't see this 172 network, right? But now I do because of the redistribution. Now we're gonna circle back to this router 0 that's gonna be running EIGRP. So you guys can see an issue with the question and the main issue that occurs basically when redistributing with EIGRP, OSPF, and BGP, right? So boom, in router 0, let's go ahead and connect to that. Let's get out of all this here. So boom, we're gonna do this basic config, paste, and I'll let you guys take a screenshot of that so you can save it for your notes. Alright, now I need to also add this to R4 so it can talk with the EIGRP router. So on the interface gig 2 and EIGRP is the main thing we're gonna add. So guys, take a screenshot of that. This is another added config to R4, right? All it is the interface gig 2. We assign the IP address and we configured EIGRP on it, right? So boom, exit. Now we have to set up redistribution EIGRP into OSPF, right? So let's go back. Boom, COMT. I'll do this one actually step by step. It's not too many commands. It's real simple. So COMT router EIGRP 100. We're gonna redistribute OSPF 1. I don't know about you guys. Redistributing starting from EIGRP is always annoying because it has the metric and all that. But once you do enough of them, you'll get the hang of it. So 1, 2, 3, 4, 5, 6 zeros. 1, 255, 1, 1500 NTU size. Exit router OSPF 1. Redistribute EIGRP 100. All right. So now we have redistribution set up both ways. EIGRP going into OSPF and OSPF going into EIGRP, right? So boom. We're gonna scroll down and now we're gonna go on to the router 0, all right? Boom. Let's end here so we can go back. So now from router 0, we're gonna notice how you can see external EIGRP routes, which are coming from OSPF and BGP, making them external, right? So boom, we're gonna show IP route. So boom, you see all these external routes. You see there's a route for 10.200.250, which was the IP on R5, right? So we see that, and we see other networks coming from the BGP, and we see that on EIGRP external routes, right? Here's the kicker though. Here's the kicker. Check me out. Here's the kicker. If we try to ping 10.100.200.1, it's gonna fail, right? It's gonna fail. How is it gonna fail if I got the route right there? Well, let's talk about it. So, boom, ping 10.100.200.1. Boom. So this should fail. You see, we're not getting the pings back. So this is gonna fail. So even though it's in the routing table, it's failing. So let's talk about that. So let's look at R1's routing table. Show IP route. Boom. It does not have any routes to get back to R0. R0, again, look at what IPs it got set up on it, right? That 10.20. Nowhere in the routing table does it have that on R1. So even though the R0, the EIGRP router, has a route here, the pings are never going to be successful because they can't travel back to R0, right? So it doesn't have a route to that 10.20. So again, basically traffic doesn't know how to return. So why did EIGRP learn about BGP routes, but BGP did not learn about the EIGRP routes? So that's kind of the original question that was asked from the beginning. So if we look at R5, right? Let's go ahead and do show run. All right, so we're gonna see OSPF and we're gonna see BGP, right? So the reason why EIGRP routes are not being learned in BGP is because when redistributing from OSPF to BGP, the default behavior is to only redistribute internal routes, which EIGRP will show up as external since it's being redistributed into OSPF. So let's say that again, make sure you guys understand. So the reason EIGRP routes are not being learned in BGP is because when redistributing from OSPF to BGP, the default behavior is to only redistribute internal routes. So let's look at R5. Boom. Do show IP route. So check this out. 10.20.30, which is the route coming from the EIGRP router. What's it getting? It's getting OSPF external, right? So what did I say the default behavior was? Is to only redistribute internal routes. So you got these internal routes. You see 172.16, that's an internal route. That's being shown here. Why? Because it's an internal route. But this 10.20 is an external. So the default behavior is not allowing that, right? So what do we do about it? We have to do just a simple command. It's a quick fix. So we would go into router BGP 250, redistribute OSPF 1, match internal, external 1, external 2, and then we end, right? Now when we go to router 1, we should see that new route. Boom. That new route, remember 10.20.30? That wasn't there before. Why is it there now? Because we did a match internal, external, which is going to grab those external routes and basically bypass that default behavior. So it's a lot of, what's the word? I can't even think, intricacies, whatever. Dude, I don't even know what the word I'm trying to think of, but it's a lot of stuff you gotta know when you're a network engineer. Oh, just caught a cramp. Alright, so back to what I was saying. God, that was horrible. So again, we are now seeing the route because we did that one command. Let's go back to the command so you guys can see for your notes. So make sure to screenshot that and take notes, and you could look this up further in Cisco documentation. But again, this match internal external is gonna help bypass that default behavior. So why were the routes not being learned? Because we were not doing the internal external. So if you ever get a question like that, make sure you remember back to this lab that you did to remember the default behavior. Because I think I got maybe four is too much, but I got 3 to 4 questions on this on my CCNP ENARSI. regarding this kind of topic. So 3 to 4 might not seem like a lot, but it's a real simple topic to learn. I wouldn't say simple, but if you get this, that's 3 to 4 points worth of questions you're adding on to be able to pass the exam. So you gotta be able to pass as many questions as you can to earn all those points, because when you're taking these CCNP tests, I can't imagine the CCIE. There's a whole like videos of how to fail a question to pass another question, but I'm not gonna get into that. But yeah, you want to make sure you get as many points as possible. So learning this in detail and taking notes is really gonna help you. If you guys enjoyed this video, please smash the like button, and please check out the CCNP ENARSI Labs playlist, where we cover different topics like DMVPN, route redistribution, policy-based routing, all that. So check you guys on the next one. What we should do is redistribution with tagging, and I have that one here. So boom, let's go ahead and start this up. Alright, so what we're gonna be doing here is, imagine this router 1, router 2. This side of the interfaces is gonna be OSPF, so you can consider this a loop back, or I put literally a physical router just so you can actually see it. And this side is gonna be EIGRP. So sometimes when you do redistribution, you can cause overlapping, or like basically a repeat. When you do like a trace route, you'll see it like the routes are looping, and you don't want that because it leads to, inefficiency. It's inefficient. You create routing loops, and that could create bigger problems. So when you do redistribution with tagging, you're making it so it doesn't keep looping around. All right. So let's look at a question here that I had. So a network administrator configured mutual redistribution on R1 and R2, which caused instability in the network. Which action would resolve this issue? So the action that will resolve the issue will be setting a tag in the route map when redistributing EIGRP into OSPF on R1, and match the same tag on R2 to deny when redistributing OSPF into EIGRP. Alright, so what is that going to look like once this lab starts up? We're going to go ahead and start configuring it any day now. Boom. So the reason I got two, this is basically the same thing. The reason I got two of these is because I want to show you guys at the end of this what it looks like when you do it right, and what it looks like when you have the issue before putting in the tags. So this is going to be the one we're doing. This is going to be the one without tagging. So let's go ahead and console in to R1. So boom, I'm gonna console in R1. Since we're running short on time, I only set it for an hour. I'm gonna copy paste these commands real quick so you guys can see. So all it is for this one is these commands to initially set it up. Just setting up the interfaces, that's all. You're configuring OSPF and EIGRP on it, obviously, as you can see. So real simple. Let's keep going. So let's go to R2. Boom, R2. And let me know in the comments down below if you guys prefer I literally type it in step by step, or I just copy and paste in the commands from my notes and talk about it. I don't know if you guys, if it kills you on time to be watching me type it in one by one, or if it actually helps you mentally see. I personally like seeing people do it step by step so I can follow them with it. Alright, boom. Router 2. Same thing. This one is going to have a loop back on it. So boom, same thing, just configuring the IP address and OSPF and EIGRP. Router 3. Boom. Simple. Router 3, we're just setting that up. Alright. So now we're going to get into the redistribution part. So this is the part that we're going to be looking at. So boom. router 3. Alright, so router 1, we're gonna go ahead and do configure router OSPF 100 redistribute EIGRP 100. So it goes like this. I saw this on a video and it really stuck with me. So whatever you want to redistribute into, you gotta go into that. So basically, if I want to redistribute EIGRP into OSPF, I gotta go into OSPF first. As you guys saw, I'm in router OSPF 100, and then I redistribute EIGRP from there. So whatever you want to go into, that's where you're going into, and then you're redistributing the command. That makes sense. I'll say it again. If I wanted to go OSPF into EIGRP, then I would go EIGRP and do redistribute OSPF. So same thing. So let's finish this command up. Boom. Let's exit that. So now I want to redistribute OSPF into EIGRP. So boom, router EIGRP 100, redistribute OSPF. Remember, when you're doing it from EIGRP, you gotta do all this metric stuff. So boom, metric 1 million. Jesus, I gotta count the zeros every time. 2, 3, 4, 5, 6, 155, 1500. Alright, let's end that. Let's go to R2. Boom, COMT router OSPF 100 redistribute EIGRP 100 exit. Now we're gonna go redistribute OSPF into EIGRP. So boom, router EIGRP 100 redistribute OSPF. The metric stuff. Let's go 1, 2, 3, 4, 5, 6, 155, 1500. 1500. Alright, so boom. So let's do from R3. Let's go ahead and do a trace route to 10.10.10.2, which is, let me look back at my notes, 10.10.2 is the interface gig 1 of R2. So right here. So boom, let's go ahead and do a trace route to that. Oh man, Saturday labbing out. I'm trying to help the people, man, because I know y'all like these videos. Hopefully this is showing y'all what it is. Alright, so notice that there was a loop here. It started with 10.10.20 and it ended there. So obviously that's a loop. You see it repeat more than once, you got a loop. So again, to handle this, you're going to want to do the redistributing with the tags. So what we're going to do is we're going to go into router 1 first. So the first step is we want to make an access list. So access list 10 permit 10.10.10.0. Permit the other IP 10.10.20.0 255 route map EIGRP to OSPF tag permit 10. We're gonna do match IP address 10. Which, when you do match IP address 10, that's just matching the access list 10. So match IP address 10, and we're going to set a tag of 100 if it matches that access list. We're going to exit, and then we're going to go into router OSPF 100. We're going to go into redistribute EIGRP 100. Boom. And then we're going to actually do it with the route map applied. EIGRP 2 OSPF tag. Boom. Let's make sure the command took section OSPF redistribute OSPF. Alright, good. Hold on. Okay, I always get confused when I see this here. Alright, so that's good. That took. So next, we're gonna go into router 2. Boom. Router 2. Route map. OSPF 2 EIGRP deny tag permit 10 match tag 100 route. Let me exit out of here. Permit 20. So the permit 20 after the permit 10 is just a catch-all. So if it's matching the tag 100, it'll go into permit 10. If it doesn't, it's going to go into permit 20. So you just want to do that to avoid your traffic dropping. So boom, exit, router EIGRP 100, no auto summary, redistribute OSPF 100 metric. 255, 1500, route map, OSPF 2, EIGRP, deny, tag, exit. So we're gonna go to the mirror topology. So before I show you guys the finished result, let's make the mirror topology real quick. So let's console in, boom. And I'm just gonna copy paste it real quick. Boom, let's go to router 2. Almost there. Alright, boom, router 3. Basically this one. I got lazy, I didn't name them like duplicate or whatever. Boom. Alright. Let's enable redistribution. Go router 2. Alright, so let's look at this R3, the OG R3, the real R3, and we'll go to R3 here. Let's clear some of this stuff out. So boom, R3, let's do a trace route again to 10.10.10.2. So on this one, there should be no loops occurring. No loops occurring now. We saw earlier there was a loop. It should be no loops occurring. So let's confirm that. And while that one's going, I'm going to do the same thing here. Trace route. Boom. 10.10.10.2. Why the hell is this thing not working? Let me see. This is good. This is good. Now we're troubleshooting why it's not working. So let's see. Why is this still showing a loop? Let's go ahead and troubleshoot why this is not working. I know why this is, because I actually changed these IPs just to not be confused. Alright, bro. This literally was breaking my freaking head. Sometimes modeling labs is weird as I don't know what. literally crazy. But it was my fault though, because in my notes I had a misspelling. I originally did for R2. I'll show you guys here. Show route map. So originally I had done for the sequence 10, I had done a permit matching the tag 100, which is wrong. You want, like we said originally in the question, you want to deny it after R1 tags it. Because if you're permitting, it's basically like you don't have a route tag. So I didn't do the deny, I did do it now. And for whatever reason, I was literally troubleshooting. I stopped the video, but I was troubleshooting for like 30-40 minutes. And I was like, all right, Monolabs is weird sometimes. I literally restarted it and put the configs on again. And now, as you can see, it actually does not have a loop now. While this one, trace route, I have different IPs. From like this one right here, 10.10.100.2 is really 10.10.10.2, but on this mirrored other topology. So as you can see, this one loops. And as we were seeing earlier, this one was looping, but now with the actual route maps applied, it's stopping the loop. So sorry for the inconvenience. This is troubleshooting. This is CCNP stuff. I can't imagine what CCIEs go through when like doing labs like this. But as you can see, I'm trying to show you guys the lab, and I already got stuck troubleshooting one. So it goes to tell you really got to be doing these over and over. And sometimes monolabs will give you a headache, and you're like, what the heck? I was doing a lab literally this week, doing route leaking from a VRF to global, from a Cisco documentation, mind you, and I did all the fans and everything, and it would leak from the global to the VRF, but the VRF wouldn't leak to the global, and I was doing that for like 3 hours, and it was literally from a Cisco doc. So I don't know, maybe the license on Modern Labs is different than the actual iOS they be talking about, but we gonna get to it. Troubleshooting is, if you don't find the solution, there's multiple ways to skin a cat at the end of the day. But hopefully you guys enjoyed this video, and I'll try to do some more labs here soon.